Alright, today we're going to talk about the second fundamental theorem of calculus. So if f is continuous on the interval from a to b, then the function f of x is equal to the antiderivative from a to x of f of t dt. And so when you take the antiderivative, you're going to end up with a coefficient, and then you're going to be plugging in your x. So let's suppose that has a derivative at every point at x from a to b. So if I took the derivative of f with respect to t, which is equal to the derivative of my interval, or my integral from a to x of f t dt, and so I'm substituting in x in for t, so I end up with just f of x. Notice that if I take the derivative of a constant, it goes to 0, so that's why we're not having this plus c, because my plus c has gone away. Because when I take the derivative of any c, it's equal to 0. So let's suppose that instead of having just an x, let's say like I have an x squared, so let's say u is equal to x squared. When I plug it in, I have to plug in the x squared, but I need to multiply by the derivative of x squared, 2x. Just as a reminder, again, a has to be a constant. If it's not, then we have to use our law of our properties of integrals to make it a constant. So for number 1, evaluate what is the derivative with respect to x from 2 to x of the square root of 1 plus t squared. So again, we're going to be plugging in that x in for t squared. If you want to think about if you're taking the derivative of an antiderivative, your derivative and your antiderivative, they're essentially canceling each other out. And so that's going to be equal to the square root of 1 plus x squared. Number 2, find the derivative of f prime of x if f of x is equal to the antiderivative from negative pi over 3 to x to the third of cosine t dt. So f prime of x is equal to the derivative with respect to x of this integral. Of x to the third of cosine of t dt. And so if you want to think about it again, that means my integral and my derivatives are going to cancel. I'm plugging in x to the third, but I have to use the chain rule. I need to multiply by that derivative of what I'm plugging in. And so I'm going to have cosine of x to the third, but again I need to multiply by that derivative by the derivative of what I just plugged in. So I need to multiply by 3x squared. Alright, number 3, evaluate the derivative with respect to x of 2x to 3 of the antiderivative of 2x to 3 of e of t plus 3. And so again, notice how my x is on the bottom. I actually have to change my bounds. And when I change my bounds, I multiply through by a negative. So this is going to be equal to the derivative with respect to x of, again, I'm flipping my bounds, so now it becomes negative. I need my a just to be a constant. And so now I'm going to be plugging in 2x into t, but then I need to multiply by the derivative of 2x by our whole entire function. And so that becomes negative e to the 2x plus 3, and then I need to multiply by that derivative of what I just plugged in, which is 2. And so that's our answer. Alright, number 4, find f prime of x if f of x is equal to x to the third of secant squared t dt. And so I need to find an a constant. So I'm going to say let a be a constant in the domain of f. And so it doesn't really matter what number it is. It could be 1, 2, 3, as long as it's in the domain. And so f of x is going to be equal to the antiderivative from x to a of secant squared t dt plus a to x to the third of secant squared t dt. And again, I need to change my bounds here because I need my a to be down here, so that becomes negative. And now I'm looking for the derivative with respect to x. And so this becomes secant squared of x, because I'm just plugging in, plus secant squared of 3x, of x to the third, and I need to multiply that by that 3x squared. And there we go. That's our answer. All right, number 5, for f of x is equal from 2 to x of 1 over 3t squared, find f of x. And so what we're going to do is we're going to go ahead and take our antiderivative. So I'm going to leave my coefficient as 1/3, and I move my t up, so it becomes t to the negative 2 dt. And now we're going to just take our antiderivative, so that becomes 1/3 times t to the negative 1 over a negative 1. And so I'm going, and that's going to be evaluated from 2 to x. So I'm going to move that t down and simplify so we can understand it better. So this becomes negative, this negative 1 times a third is negative 1/3 t, and again evaluating that from 2 to x. And so now we can plug in. So negative 1 over 3 instead of t, I'm substituting in x, so it becomes 1 over 3x minus negative 1 over 3 times 2. And so that simplifies to being negative 1 over 3x plus a 6. If we want to find f of 2, we could just plug in. So I have 1 over 3. I know what my f of x is. F of x is equal to negative 1 over 3x plus a 6. And so we just plug in. And so that ends up giving me 0. Another way I could have done it is f of 2 is going to be equal to the antiderivative from 2 to 2 of 1 over 3t squared dt. And if you notice, your bounds are the same, so that means your width is 0. So again, that also gives me 0. If I want to find f prime, that's going to be the derivative with respect to x from 2 to x of 1 over 3t squared dt. And again, these essentially your derivative and antiderivative are cancel each other out, so we're substituting in our x. So this becomes 1 over 3x squared. Finally, d, when I want to plug in 2, I can just use this guy up here and plug in 2. So I have 1 over 3 times 2 squared, which gives me 1 over 12. And so those are all of our answers.